Hey Simplifiers, we're here today to talk about getting to know your data with Elasticsearch. We all understand that in order to make good business and security related decisions, it's important to have as much data as possible. And the products that run in our environment are rich sources of data. Today, the tool that we're going to be using to examine that data is Elasticsearch and the ELK stack. So what is Elasticsearch? Elasticsearch is a Lucene-based search engine that was released around 2010. Since then, it's improved dramatically and added on log analytics capabilities as well as security panels and dashboards. The ELK stack is comprised of Elasticsearch, Logstash, and Kibana, with Logstash being on the front end to ingest data and Kibana being the UI that you use to examine that data. In recent years, that's expanded to be the ELK stack with the addition of various beats, although I prefer to refer to it as the Elastic stack. So what is the big difference now when ingesting data between Beats and Logstash? Understand that Logstash is a little bit older than the Beats and is meant to be more general purpose, and as such has much more functionality, much more input sources, and many more output sources. It's a little heavier than the Beats, since the Beats themselves are written in Go and are really meant to be single-purpose shippers with dedicated jobs. So when evaluating whether or not you want to use Beats or Logstash, if in your use case you're able to use Beats, it is the preferred option. However, it doesn't include all the same capabilities as Logstash, and so you may still need to use Logstash depending on where you choose to ship your logs. So speaking of the Beats, Elastic has developed quite a few at this point. In short order, we have FileBeat, which is really meant for ingesting log files from servers. We have MetricBeat, which is really meant for collecting system metrics for infrastructure monitoring. We have PacketBeat for looking at network traffic, WinLogBeat for the Windows event logs, AuditBeat, which is mostly for Linux auditing, although you can install it on the Windows platform as well. We have Heartbeat for availability and FunctionBeat for cloud logging function as a service. Now, using these beats, there are many benefits. On top of being lightweight, there are also modules for some of these. And so we're going to look at specifically FileBeat to look a little more in-depth as to the capabilities. So understand that there are modules, and modules give you many benefits, including creating dashboards for the data you'll be receiving inside Elasticsearch, as well as normalizing the data into the Elastic Common schema. And that's very important to do because once your data, all the sources can have varied field names. But when you normalize those fields into the Elastic Common schema, Elasticsearch expects the data to be in that format. All of the machine learning jobs, all of the dashboarding are all created based on the field names provided by the Elastic Common schema. Should you choose to go the Logstash route, or if your log source is not supported as a module under one of the beats, there is some transformation that will have to manually take place in order to rename all those fields. But if you're able to use one of the modules provided by Beats, all of that is done automatically for you behind the scenes, which saves a lot of time. Understand that with Logstash also, you have the ability to transform the data inline through the filtering section, whereas with Beats, that's a little bit more restricted. So usually whenever you use Beats, there's little modification that takes place on the Beat side, but then you may wish to create an Elasticsearch ingest pipeline that modifies your data so that it really truly shows up within the index in the format that you wish. So we're going to hone in here and use FileBeat as a more specific example of the capabilities that are available to us. So as I said, there are modules. Modules include Apache, IIS, CEF, Kafka, Suricata, Zeek, and dozens more. All the work has already been done in normalizing all of those fields from the logs so they can be cleanly ingested into Elasticsearch with very little work done in the ETL pipeline. And as I said, this provides us the ECS capabilities, and then it also gives us dashboards within Kibana that are very specific to the type of data we're ingesting. Once you have some data in Elasticsearch, you need to manage the data. And by that I mean you can't just keep pushing data into Elasticsearch without ever cleaning it up. Otherwise it becomes unmanageable. To that end, we have index lifecycle management policies. And whenever you load up a beat, it will create a policy by default for you. Now, I believe it's important to go in and modify this, since really all that's going to do is change the logs every 50 gigabytes or 30 days. I prefer to go in, change it to be either maybe a daily log or a weekly log. Makes it easier to manage. And then you can also set the various stages of your data, whether or not you want to go from hot to warm to cold, and after how much time does that data get automatically deleted from the system in order to make your job a bit easier. So once we now have some data flowing into the system, and we'll get into a little bit more detail in a minute with the diagram, and we're managing our data with an ILM policy, it's important that we're able to examine our data. And this is where Elasticsearch and Kibana really shine. The ability to drill down to each field, to only show what it is that you want, to exclude the things you don't want from your view so that you can truly see what's there. And to that end, not only do you have the Kibana UI, but you now have the specialized applications that Elastic has put into the Kibana UI. Two examples of these are the SIM app and the infrastructure monitoring app. So the SIM app will include dashboards for threat hunting, anomalous processes, things of that nature. The infrastructure monitoring app goes hand in hand with Metric Beat that we discussed before, with really no configuration, gets you all of the metrics for your infrastructure. So let's go a little bit more in depth as to what this actually looks like deployed on your network. So as you can see here, we have a diagram of a network. In the center, we've got one server running Elasticsearch and one server running FileBeat. You can obviously run both of these on the same server if you so desire. So I've given a little example here where on the top we've got our firewall and our IDS. So we're going to configure FileBeat with a syslog listener. It's a very simple configuration. You just tell it that you want to listen for syslog messages, you tell it the port you want to listen on, and that's all the configuration that's necessary. Once we do that, we can go ahead and tell our firewall and our IDS to send our syslog data down to our FileBeat agent. We can do the same with NetFlow data, and even more so, there's a module for NetFlow data that'll enable us to parse that data. From FileBeat, we're going to ship directly into Elasticsearch, and that is the beauty of the beats, is that most of the time they allow you to ship directly into Elasticsearch without a middleman. Continuing on with our example, we've got down here an Active Directory domain controller as well as an Apache Linux server. So on the domain controller, we'll go ahead and install WinLogBeat and Metric Beat. Metric Beat requires basically no configuration. For WinLogBeat, you're going to want to go ahead and go into the config file and tell it really which log sources you're most interested in. Please don't just consider the system and application and security logs. Understand that now in Windows there are much more granular logs, including PowerShell, which may be of interest to you. All that can be easily configured right from the config file for FileBeat. Also on our network, for our Linux server, we're going to install a couple of different beats. We're going to install Audit Beat, which will really give us our login and other very crucial security data from that server. Metric Beat, so that we also can monitor it on the infrastructure side. And now we're going to install FileBeat and enable the Apache module, which will do that parsing of data for us. Now, ideally, you find yourself in a situation where you have a lot of data within Elasticsearch. Some of it has been normalized and is in the ECS format, but some of it won't be. Now it's important, now that you have this holistic view of your data, you can see what further transformations need to take place. And now this is where we circle back around and we look at our Elasticsearch ingest pipeline. This pipeline, whenever you go ahead and you deploy a beat, is created on the Elasticsearch server automatically, but it's there for you to modify as well. So anything that you need to do regarding renaming, removing, adding, all of that can be done through an Elasticsearch ingest pipeline. Unlike if you went the Logstash route, it would be parsed within Logstash. So now really the next step is to go in and see where you have messages in Elasticsearch that need to be parsed out more, because large blobs of text don't do you much good. What you want is every single piece of your message parsed out into individual fields, which allows you to then go ahead and sort and look through it in Kibana. And now you should be at a place where what you really need are more ingest sources, right? There is no harm in ingesting from various sources to potentially various index names to give you a good sense of really, once you're able to see it all, what is it that you want to keep? What is the duration of time for which you want to keep it? And what information, now that you've been able to parse it, is really of no relevant use to you? That can obviously be discarded. But now you should find yourself in a position where you can use Kibana to go ahead and dissect all of the data that you have available to you. This comes in very handy down the road if you're looking to then ingest into a SOAR solution. It's important to differentiate the events from the alerts, and then whenever you go ahead and you ingest that data somewhere else, you need consistency. And really, this is where you can visually parse the data for consistency before that next step. Hopefully this leaves you in a position now where you're able to examine your data and get to know your network in a little bit more detail. It was a pleasure seeing you today. Thank you.